So here we have some code that's on Avenue to Learn. It's pretty basic for just getting the points around a circle and drawing at them. It has a variable here called angle that lets you rotate the whole circle. If we didn't change angle, like so, if we got rid of that line, we would just have these points static on the screen. But that's really handy because that tells us that this code right here lets us find the points around a circle, and the reason why they're spaced out like this is because of this number 15 here. If we change that to like 60, there's going to be even less points because it counts up in 60 and stops when it gets to 360. So if we did 120, that should be half the points as a triangle. So you can make a lot of interesting geometric shapes just by trying to draw points around a circle and only drawing them at certain intervals. For example, if we did frame count percent, let's see, we want it to go up to 360, so we'll just do frame count percent 360. And if we do that, we'll see that the shape changes over time until it becomes just a single point, and then it restarts again, or it should restart again. No, it should only go between 0 and 360. Interesting. We should see it come back around here. Well, let's find out what that math is actually doing. This is a good time to learn about the print line command, which lets you check what actually is coming out of a command. So we want to find out what's happening when we do frame count percent 360. It goes up, it gets to 360, and then it goes back to 0, but it doesn't do it again. Well, what's frame count then? It seems the frame count gets stuck at 360, possibly due to some glitch. Oh, it gets hung up because it's adding 0 at that point. So what we can do here is we'll just offset it by 1, or do percent 359. Nope, it has to be that. Okay, here's the easiest way to do it. We go in here and we say if frame count percent 360 is 0, theta plus equals 1, and that should prevent it from getting hung up in there. Let's see if it restarts. Yep, there we go. So now we have a looping animation here that shows how you can use different amounts of points. And if we slow the frame rate down, maybe to half speed, or even less, let's do less. If we slow it down, we'll see how these individual numbers lead into different types of points. So you got a square, triangle, then you're left with a simple line until it merges at the bottom around 360 degrees. Very helpful to know that in case you want to make some cool shapes using math, but you can also just put triangle coordinates in because processing has that. Anyway, let's throw that back to 15, get rid of this, and if we leave it at 15, we have evenly spaced dots 15 apart, 15 degrees apart, because we're working in degrees. And then the code that generates each of those XY positions is basically going to be the distance, how far out from the center of the circle. So if I put my mouse in the center, from here to this dot is about, what did we say, 100 pixels. And then we have some interesting math here that's pretty much just copy-paste. And I'm explaining this just so that if people are watching the video can catch up to what the code does, and then we can move forward. Anyway, it's pretty much copy-paste. This angle value here, because we're not changing it, we could take it out, and it would still do the same thing. It would still show the same shape. The reason why we throw that extra angle in there is to make it rotate. And you'll notice here there's something called radians. That's just because in processing they work in radians, like pi, 2 pi, whereas we like to work with degrees in real life. So we'll switch it back to degrees down here, turn it on, and now we can see it's moving again. So a few more commands that we see here: the push matrix, the translate, and the pop matrix. And I'll demonstrate those really quickly. So if we have void set up, and we have our size of 320 by 240, and we go void draw, and inside here we clear the background, set a stroke of 255 for white, stroke weight of 10, and if we translate it somewhere, let's say translate to half the screen, half width, half height, and we put a point there, so it would be 0, 0 because we're moving the whole 0, 0. You'll see we have a point in the center. Now if we were to go and put another translate, and say we want it at 100, 100, what we'd imagine is it'd be something in the center, something at the top left at 100, 100, but what we actually see, that's a little bit too much, I'll change it to 50, 50. What we actually see is, oops, I forgot to draw a point, that's why. So if we draw another point there, put that back to 100, 100, what we actually see is the point goes further south and east from the central point. So the reason why it does that is because it's translating from what it was translated from before. So there's something called push matrix that lets you store where it started, and pop matrix that returns to that point. And if we do that just once, now it's drawing at 100, 100 because it goes to the middle, puts the point, pops the matrix back to here, then goes to 100, puts the point, but there's no pop again. So we always want to make sure that if we use translate or rotate or whatever you're using, make sure it's surrounded by a push matrix and pop matrix if you don't want it to stack. Now, there's some cases where you might want it to stack, and I'll demonstrate that. Let's say that you wanted to translate to half the screen height and width and put a point. Then from there you wanted to go 10 to the left and put a point, and then from there you wanted to go let's go 10 upward and put a point, or 10 downward. So now we have these points that are side by side, and you can see that they continue from where they were before. So if you were using a for loop or something like that, you might want to use that as one way of making something that maybe goes zigzag or creates a pattern. For instance, if I do this, for in I equals 0, I less than 10, I plus plus. And we can make it do this 10 times of going down and placing a point, then going right and placing a point, and just keep alternating it. Then we'll see that it builds this diagonal line of circles for us automatically. So that's one case where you might not want to do a push-pop matrix, but odds are you'd still wrap the whole thing in a push matrix and a pop matrix, so that you can still draw some text on the screen where you want it, or put a line from 1010 to 110, which is there. Oh, we gotta put this outside. Okay, so yeah, if we put that there, we push pop the whole thing. Now it'll do it from here to here for the line, while still doing that cool zigzag pattern. Might as well show rotate while we're here. If I wanted to, I could do this. I could translate to that point, and it's clearing the background every frame, so I should be able to put rotate let's see, radians frame count, divided by 360. So it's going up 60 frames a second, which means it would be going up, let's say this makes it go up 1 degree a second. That's a little bit slow. Let's make it 2 degrees a second. And now you'll see that we have this line of circles that rotates around on the screen. We can make it go faster, maybe make it 3 times faster. We can make it just go crazy, not divided at all. And now we see this line of circles, thanks to translate and not push popping, it continues the offset for them. But the only problem with this is you don't really know mathematically where these circles are when you're not using push and pop matrix. So if you want to do something interactive, I'd recommend doing it a different way, using the method on the other code that we have on Avenue to Learn, because this method here is only a visual effect. You can't get the coordinates of where the endpoint is. Anyway, so that's push pop and translate and rotate. And that's pretty much it for this code. There's nothing really else going on here. It's using some basic push pop, translation, and around this center point it's placing these dots based on their angle. So now let's work on making this into a function. The very first thing we'll do here is we'll make a function for it called void, and we'll call it point circle. And right now we'll just cut and paste all the code for it. So we'll take that entire bit of code. Actually, we'll take everything. We'll take everything up into the background, because sometimes you want a function to have different graphics, different stroke widths and heights and colors and things. Anyway, so that's pretty much it for now, and we call it point circle. Now this doesn't really do much for us because it's not adjustable. So the first thing we could do is we could send it in X position. So maybe instead of width divided by 2, we'll send it mouse X, mouse Y. Now it's going to get mad because there's no parameters expected, so we have to add parameters. So we'll call it X and float Y. And we'll replace this with X and this with Y. And we'll see here that because we already used X, we need a separate X. So we'll call it X pose. Now if we run this, this will go to the center of our mouse and rotate around that mouse. So that's cool. That's a good start. Maybe instead we can replace distance with a variable. So we'll get rid of it up here, our parameter, sorry, and we'll pass it in here. So instead of 100, let's give it 10. And now it fits around the mouse. You can see it's actually only 10, which is very small. But if we were to put it to 100, it'd be 100 around the mouse. So we've made it customizable. We've turned it into a parameter that can be passed into the command, and it comes out on the command side as dist. And so we still use it as dist down here. But instead of being at the top, now it's part of that function. Really handy stuff. So that's pretty much that for there. We'll leave the angle as a global variable in case we want to draw different circles, by the way, which we can now do by just copying that line, and we could place one at the center of the screen now still. Height divided by 2. Let's shrink down the distance to 50 for both so that they don't take up the whole screen. And now you'll see we've got 2 circles on the screen turning around quite happily. Not much else going on. So let's figure out how to turn these from functions into objects. So what we'll do is we'll make a new file for it. So we'll save this as, and we'll call it circle point class. And we're going to give it a new tab. You don't have to, but it's easier that way. So we'll call this new tab a point circle. And we'll call it class point circle. And basically what we know about these is that they're going to have an X position. they're going to have a y position. They're going to have a distance to draw the points at, and they're probably going to have their own internal angle. So we're going to have to call it something different because we've already called it angle there, so we'll just call it ang. Okay, so that's pretty much it. We can copy this code here and put it into a new function inside of the class called maybe void render, or maybe void update, since it does more than just draw the graphics. It also updates the angle. So if we do that, we see here X pose and Y pose are already ready to be used. Dist is already ready to be used, and the only thing different is instead of angle we put ang. Ang equals plus 0.1. Now what we could do is we could add a rotate speed, and instead of putting plus that we put rot speed. We could add another variable for float or integer this time and call it num points or num degrees, num degs. And right now it'll be 15, and we'll replace that 15 with that, num degs. So now we have pretty much the same code as before, but now this object it's truly an object that has points drawing on it, and we can customize a lot of the values. We can customize the degrees, we can customize the speed. So let's make the code to turn it into an object that you can create by adding something called a constructor. You don't need to know what it's called, but it is called a constructor. And all you do is you do float x, float y, and I'm using different names here because we're going to pass them into the memory. We don't want to have the same name. So rot and int nd. So just like that, we take our x pose equals this x value. The y pose of this object is going to be equal to the y that we pass. Distance is going to be equal to the d that we pass it. Angle is going to be equal to the a that we pass it. And rot speed is going to be equal to the rot speed. And numdegs is going to be equal to numdegs that we pass it. So there's a lot of data we have to pass this when we create it. We have to tell it all this information about how many points, how fast to turn, the angle it starts at, the distance between the individual points in the center of the circle, and the x and y at the center of the circle. A lot of detail, but this is really cool stuff because now we go up here in our code, we completely comment this out using the quick comment tool. Oh, it's not really a tool, it's just keyboard code. Anyway, we type that in, that's all commented out. We don't need this command anymore, so we'll just comment it out as well. We also don't need this angle value, so I'm going to comment that out. And I'm going to create a point circle, PC. And we're going to fill that later in the setup. So PC equals new PC, and it's expecting an x and a y. So we'll just do width divided by 2, height divided by 2. It's expecting the distance from the center, 10. It's expecting an angle started at 0. And it's expecting the rotate speed, 0.1. And it's expecting the number of points, which is going to be about 15 degrees. And we have to say new point circle, sorry. Bless you. And then all we have to do is pc.update. And it's going to still draw that circle on the screen. And 10 is a little bit short, so I'm going to make it wider, 50. There we go. So now we have something that's in the form of a class. So I'm going to get rid of this old code here. It'll still be there in the video and in the version that I've uploaded aside from this function. But now we have something that's in a class. It's technically an object and it's easier to control them. By default, we don't have any way of changing these values, so we could add things to change them. We could say void set position. I'll do lowercase. And we could pass it an x, pass it a y. We do x pose equals x, y pose equals y. And that won't do anything yet, but we could make some code for it to tell it to do something. So we could go pc.setPose, pass the mouse x and mouse y. And then if we run this...
Can I eat this?
Yeah.
Is that milk bone?
Yes. Sorry.
It's all good.
Anyway, it's now positioned at the mouse. So this code will be uploaded to Avenue after we're done here, and along with the video that we're recording right now. So we have this little object here, point circle PC, and it sits at the mouse. We can move it around. We gave it the ability to change that there. We have a lot of control over this. We can change the rotation speed, the number of degrees, the angle that it's at. We can force it to change. We can change the distance. So there's a lot of things that we could do, and we just have to make the functions for them, like void set distance, float d, and dist equals d. If we're doing that, we'd probably want one called getDistance to get what it is already. And when you make something that gives something back, you need to tell it to return, and then you pass the value that you're trying to send back. So now what we could do is we could store a float called startDist and make it 50. And what we can do here, actually we don't need to do that. We could just do this: if pc.getDist is greater than 25, pc.setDist, pc.getDist minus 1. So it's going to shrink down until it gets to 25. What we could do is throw that into an else statement, if-else statement. We could say pc.setDist back to 50 as soon as it gets too small. So what we'll end up here is with a circle that gets smaller every frame. Kind of neat. Kind of moves too fast, so we could decrease it slower. And now you'll see it's still rotating and decreasing. So that produces a really neat effect. You could actually make it go a lot closer, like maybe greater than 5, and maybe a little bit faster. And if we set this to an extremely high number, then we'll see something that comes in from the outside as it's still rotating and focuses in on a single point. This is a really great visual effect. A lot of video games use this effect. It's pretty much a good way of attracting someone's attention to a central point, making something look interactive. And it's a very low-cost effect. You can see that the code is very short. So yeah, that is turning it into a class. So now we can look at how to turn it into an array. So once it's in a class like this, it's pretty much just a matter of saying, okay, let's make an array of point circles. And we'll make it new point circle, and we'll make it 10. Yeah, 10's fine. And then everywhere that we use it, we're just going to do a for loop now. And go until it's equal to 10, and add up through it. So all we do is everywhere where it says PC, we just do new PCI. And maybe what we can do here is we can do 50 times I to start with. Same down here, we have all this code for PC. We go int I equals 0, I less than 10, I plus plus. So 10 is the number that I chose for how many to make. If I made a variable for that, it would be different. I'll demonstrate that in a minute. But basically anywhere where it says PC, change it to PCI, because now that it's telling the computer that we have lots of them to look through, and they all need to be treated the same. So there we have it. Now we have all these circles that are falling in on the center. And you'll see that once they've hit the center, they start from the same position. And so we're going to eventually find a point where the outer edges are no longer coming in, and they'll stop pulling towards the center. although it seems to be taking its time to do that. So maybe the trick here is to set the distance to 50 times I. So basically set it to the same as it started at. See if that makes a difference. Seems to make a neat effect. I'm not quite sure exactly what's going on with the math. I'd have to check it out. But it is producing a really neat effect that seems quite random, but still shows patterning. It just doesn't repeat the same pattern every frame. So this is a pretty neat thing you could do. And if you were to do just a small change to your point circle to draw, let's say, a white point after it draws a line underneath, so we could do stroke, let's do a gray line, so very transparent, and do a line from 0, 0 to x to y, and then draw a point there. So we'll probably do a stroke weight of 2 for the lines, and then another stroke weight of 8 for the points. If we do something like that, take it out of here, and run it, this is what we have now. We could even maybe make the lines thicker than the points. Now we end up with something like this, which I think looks pretty interesting. I'd say that's a really interesting work that could almost be counted as, actually it would be counted as a full generative art because it's got classes, it's got if statements, it's got variables, it's got functions. The functions are inside the class now. So in a way, yeah, this would be considered a full generative art project, as it is right now. I mean, it could always be made a little bit more interesting in different ways, maybe using different colors. The use of transparency seems to be what makes the interesting points of the lines that we see here when they overlap. They could be made much wider to make. Actually, yeah, let's experiment with making it colorful. So we'll give it pastel colors to start off with, and we'll increase that stroke weight to 32. If we run that, we can see now that it's producing quite an interesting little pattern without very much change to the code. We've added 3 extra lines of code, and thanks to the fact that it's all in an object, the effect replicates across all of the points. And it just makes something that's really nice to watch. Let's try changing this one up with completely random full color and see what that does for us. Pretty interesting. I like how they kind of compete at the center of the circle. I definitely feel like this would be a viable project. If we increase the brightness of if we increase the opacity of the lines, it starts to form something a little different. Not sure I like that as much. Maybe we could try less. Yeah, less is definitely more here. So thanks to the transparency, the way they overlap produces the more interesting patterns. But that there is a lot more interesting than just random shapes on a screen because it is generative art. It's something that's doing something unique each time. And if you wanted to put some more randomness into it, you could basically take this code here that sets it to I times 50 and do random 50 times I minus random 25 times I. So it's always going to be somewhere between where it started before and halfway. If we do that, the randomness will make things a lot more varied. And that just like that, we have a fully functional generative art piece. Pretty cool. Maybe we can do this to 100 times I. Yeah, so that's how to use functions and classes and and circle points and lines to make a really interesting effect. And now's a good time to look back at what we did and find out how we got there. But first of all, how do you feel about knowing that this is kind of a acceptable outcome for the project? Does that seem pretty fair?
What kind of grade would you give that?
This project would probably be, I don't know, it's very mesmerizing, and it's unique each time you run it, so it's definitely high up there. I would probably say at least a B+, if not an A-. Depends on how the code is written, how well it's commented. There's a lot of other factors that come into it, but as a visual effect, I find it really interesting. Maybe some color scheming to make it more patterned in the colors would be neat. Maybe combine this with other visual effects, draw other things on top with other types of objects. But as it stands, like, this is an incredibly captivating artwork piece that reminds me of, like, I don't know, small town fairs, like the rides that come to those fairs. And it's got this constant pulling to the center that draws your attention and creates depth. It's a really interesting piece. I would say that if someone was to do this, something like this, because now that we've done it and it's on video, they can't do it, unfortunately, but something like this would be pretty reasonable. A very good project. This course allows for both abstract and non-abstract, so you can use abstraction like this if you want to for your generative art, or you can make more literal representations. It's up to you. But this would be a very good project. In terms of the complexity, it checks all the boxes. In terms of the interest, it checks most of the boxes. How does that make you feel about the project overall?
I still have no idea how to do classes, but it makes me feel better that it looks nice.
You were unable to attend on Thursday, right? When we taught classes in class?
I was there for half of it, but
Okay. Were you able to catch the slides on it?
Yeah, I should have.
Okay. Okay, because the slides are the most important part of classes. The ability to understand that a class is sort of like you're writing code for all kinds of things that fall under that class. So like you're writing code to say what all apples are like and all chairs are like. You're writing it like that, and then you make lots of copies of them. It's sort of like, you know what this is going to be in this Pocky box because it says green tea Pocky. So as a class, this would be green tea Pocky. And then each individual one would be an object inside of it that does the same thing. You can eat it. So I guess that's kind of the key there, is that a class is just normal code that you would do for one thing, but written in such a way that you could do it 100 times. Like right here, we're doing it 10 times. If we were to do the final change I was talking about earlier, and add a number of circles, and set it to 1 instead of 10, here's what that would look like. Everywhere that we use 10, we throw 1 in, and then we run it, and there's only one circle going on. We change that to 100, and there's 100 circles going on, and you can see it's not even got a chance of keeping up. But we put 20 in, and you've got a more complex, interesting pattern. So it's about tweaking to find out the best combination. You can see this one makes it lag a bit, but it's still visually appealing. So, hey, how's it going? Good, thanks. So yeah, this would be a very decent project. We're not really looking for anything code-wise that's more complex than this. It's more about, does it create an interesting visual? And I think this one is just on the balance between being interesting and being too random. So when you have it with like even 5 rings maybe, Yeah, a little bit of a sparse texture that pulls attention towards it, but also creates this unique pattern that repeats randomly with a small amount of randomness. That's an excellent project. So the point of putting them in the class is just so that we can duplicate the code lots of times. And if we wanted to, we could do this. Mouse X plus I, maybe, and mouse Y plus I. And what that means is each one's going to come from an angle. Let's do I times 10. So this should put them diagonally down and right based on the number in the sequence. So we have like, I think 5 of them running, and you'll see that each of them are centering in on themselves. So it creates a different effect just by doing that. If we change the num circles back to 10, and we change this from times 10 to maybe like times 20, you'll see that you've got this chain going on, and each one gets pulled into its own center at different speeds. Can you see what's happening there? That would be considered really interesting as well, because you can see it's producing like these fractals. You could actually hide the points like so, and you'll see these interesting color fractals, very faint color fractals forming. So do you see how a small change there made a huge difference? So, you know, it's pretty cool. You just gotta try them out, see what happens. If we put those back to where they were, so I'll just comment that whole line out and just do mouse X, mouse Y. You still have a really interesting pattern happening there just by commenting out the points. So just for the video's sake, I'm going to put this back, the points. I'm going to leave this at 10. I'm going to run it to make sure it's still the same. And I'm going to upload that to Avenue to Learn. And all it is a simple class. So let's take a look at the class and figure out how it works now. I'm going to have to decrease my font size a little bit just so I can fit it all on the screen. Hope that's okay. Still not fitting it all on the screen. Can you still see it okay though? Okay. So what we've done here is we've created variables that are kept inside the class. So it's sort of like this Pocky box. Each one's going to have an X position, a Y position, and because it's in real life, it's going to have a Z position, which is how close or far. So it's got left, right, up, down, close, far, and it's got rotation and all kinds of crazy stuff that we don't need because we're on a 2D screen up there. But it's also got maybe like a dampness. Like if you were to drop this in a puddle, it would get wet and soggy. Like there's so many different things you can attach to whatever object you make. It's all based on what you're trying to do. Like you wouldn't be worried about the strength of this if you're not doing anything that would involve breaking it. So basically, when you're making your objects, think about what you need to change on them, and that's really where you would put your variables. So with this one, I put these two options in here just in case we wanted to change the shapes they make. So instead of circles, we could throw, I think it's, if I throw 3 in, not 3, if I throw 120 in here, it should do triangles. Yeah. So the reason why is because 360 divided by 120 is 3. That's a really cool pattern too. Not as interesting as the circles. Maybe if we do 60. That's pretty cool. That forms sort of like a sheriff star in the middle. Sheriff star? I don't know. Anyway.
It's like an asterisk.
Yeah. We could throw 30 in there, see what that does. More traditional star, make a star or something. 90. perfect square.
Is it degrees?
Yeah, it's in degrees.
Can you 5?
Yeah, if we do 5, it's going to really chug.
Hey. See, that's sick.
But that looks really cool. I'm glad we tried that. So yeah, lots of options to mess with it. I'm going to put it back to 15 for now. Anyway, so that's why we created a variable there so that we can set it and it gets kept. A rotation speed, we can make them rotate at different speeds. So instead of 0.1 for a speed, we could actually make them rotate at a random speed between 10 and 0 and 1, or 10 and 0.1. And if we do that, some of them will move fast, some of them will move slow. It just accelerates the effect though. Without some code to change it, it would kind of just look the same. So and then here we have the code. So we've called our class point circle. So because we've called it that, the very first thing that we put in it is something called point circle, which is how we know how to make a new copy of that class, like a new object of that class.
Do you have to do that every time you make a new object?
Anytime you make a class, you got to make sure that there's code with the same name to make an object.
Okay.
So basically this code right here that I've highlighted is run whenever we do this. So it's like point circle becomes a function because we pass it these parameters just like a normal function. We pass it the x, the y, the distance, whatever that is, the angle to start at. So they can start at different angles. That's something cool to try out. So let's say we start them at 45-degree angles. So I times 45. Each one is offset by 45 degrees. Oh, it's kind of a perfect angle. Let's do 5 degrees. Now you'll see that it's creating a very different pattern of spikes. It's like a checkerboarding that's going on a little bit, like kind of like backgammon, I guess. Do you see it, the change in spikes? It's just because they're slightly offset from each other. Maybe we can exaggerate that with 10 and still get a neat effect, but I think it'll, oh yeah, cool. It worked. Anyway, that's the start angle difference. Put that back to 0. So anyway, we pass it those values and it knows what values it's getting because we made them up here. And then we just store those into the memory that we made at the top here. Kind of making sense? It's okay if it doesn't. It's perfectly fine. I don't expect you, or anyone really, to get classes in one day. What? Sure.
You're going to use a class when you want a bunch of objects of the same type. Like circles or something like that. Like, it's kind of harder using an example like hockey. Like if you have a circle, you have circumference, the diameter, a point where the circle's drawn on, stuff like that, and that's the stuff that you use for this, but that's because in order to draw a lot of circles in the class, but if you're only drawing like a few, you might not want to use a class. Like the point of classes as an aspect in programming is that you use it when you want to, and it makes it much easier to code something. Like yeah, you can learn to code things one by one. Like for mine, I coded like all of my appendages for something one by one. But if you're doing it, or you want to make it like, if you're doing a lot of them, or you want to make it so you can go in quickly and mess stuff around instead of like having to go to every single one, then that's when you do it.
Yeah. Like you could make a class for, let's say, a die. And, and then when you send it the code to roll, it gives you a number between 1 and 6.
Mm-hmm.
If you wanted to do 100 dice, you wouldn't write 100 lines of code. You would just make an array of a 100 die class and then tell them in one line of code inside of a for loop to say, for all the dice, roll them and get the number out of them.
Right, and like the point of a class is that I've done nasty code when I had to do Clanka in Java, and I just like wrote it out 20-something times. Like the thing about the class is that 100 is a good example, but you can also run like 10,000 if you want.
Mhm.
Or like for those points, like we only had a small window, but if you make the window bigger, you'll see like hundreds of points on the screen.
Yeah.
And it also means that we can like reverse them, or we can do other things with certain points, or we can make it every 5th point does one thing, and stuff like that. And we can even, at any point, using a class, you can go to any article in the class, so I can find the 100th point drawn, I can find out where it is, and stuff like that.
Yeah. So now this whole thing we're drawing is more complex than normal because it's not just drawing a point, it's actually a point circle. So it's drawing a whole circle of points.
Yeah.
That's why when we set it to 1, it draws a whole circle of individual points. We have these little things here, a function that gets the value of distance from the outside and a value that sets the value of distance from the outside. So over here, we do a check to see if the distance from the center is greater than 5, and if it is, we decrease that distance. But if it's not, we reset it to a really far one so it comes back to the center. And that's how we have that function that of the art where it looks like it's all converging on the center, because it really is. It gets closer and closer, and once it gets too close, it explodes out to the distance and comes back in. Then we have code here to place it at the mouse by updating the X and Y position to the mouse X and Y. So the reason why this code gets more complex is because, and this is the code to draw the whole thing for one point circle. But the reason why the code gets more complex is because we're no longer writing code for each individual thing. We're writing code that they all share, and we're trying to tell all of them to do something smart based on the information. So I think if I hit Command T here, that'll auto format it better. And you'll see what it's doing is running in a for loop that goes through all the circles, and we set 10 circles at the top. And basically, once it goes through them, it checks each one to see if it's too small, and if it's not, it'll make it smaller, and if it is, it'll reset it, but it doesn't reset them all at the same time, it just resets the one that was too small. So that's where the power of a class comes in, is that you can do code that's really short, but would do really smart things for hundreds of objects or thousands of objects. It's used a lot in games, it's used a lot in generative art, it's used a lot in databases. The ability to store code inside of each specific type of object is what makes it really possible to do crazy complex things without too much code. So yeah, I don't think it should feel easy yet. I don't think it should feel like it makes sense just yet. But I feel like it should be something that you might be able to open up and tweak some numbers and see what does what. Is there anything that might be easier explained, or do you feel like it's something you'll just have to kind of try?
I think I'm just going to have to do it on my own.
Yeah. Yeah, I think once you have a better plan of what specifically you want to do, you'll feel more confident with the code because you'll know what your end goal is, and it's easier to get there when you have an end goal.
Have you started messing around in the code yet? In the code? That's pretty much how I thought of an idea before I did my assignment, but most of the assignments, you just get into the code and just start messing around things, changing things, making things multicolored.
Yeah.
And you just have a project at the end.
Thanks, man. So yeah, I think that's it for this video and for our revisit of class. Thanks. So
You pop push matrix?
yeah, I taught pop and push matrix in the video too. It's important to know.
I know, it is important.
Okay, I'm gonna stop this video before it gets